So how close the data point is to the accepted value is accuracy. Fill that blank in with the word accuracy. Alright? How close the data points are to each other is precision. Okay? So now, if I throw darts, okay, on a dartboard, and all my darts land here, in this region of the dartboard, what can you say about the data points? Is it close to the bullseye? Is it accurate? But are they close to each other? So they are close to each other. What are they? Precise, but not accurate. So you have a line underneath on your note sheet. Is that right? So write down it's precise, but not accurate. Precise, but not accurate. Do you have your notes page? Have you written it down? Precise, but not accurate. So I'm throwing my darts again, and this time my darts land. One is here, one is here, one is here, one is here. What can you say about how my darts landed?
Neither accurate or precise.
Neither accurate nor precise. So write down they are neither accurate nor precise. They are not accurate and precise. Is that right? Does that make sense? Now, I throw my third set of darts and they all land here. What can you say about my data points? They're both accurate and precise. They are accurate and precise. Alright? So I threw my darts. 3 of them almost land here, but then one lands here, one lands here. What can you say about my data points?
Neither really, because
if you make an average of the results, can I say it's almost close to accurate?
Yes.
But it's not precise because they all don't land in the same region. Alright? So you can say it's accurate, but not precise. Okay?
So we're literally just comparing numbers.
You're literally comparing numbers. So come to the bottom. So this is how you will get questions on your test. Alright? So here is the first set of data points. Now, what should be the mass of the object? What should be the mass of the object? 5.550. But what does the student get? These are the 3 values that the student gets. What can you say about the data points?
They're precise but not accurate.
They are precise but not accurate. Do you understand that? Precise but not accurate. So if you come to the next problem set, the student should get a sample of what? What should be the temperature? It should be 80 degrees. But look at student 1's data points. Scroll down. Okay, so look at student 1's results. Alright? Student 2, student 3, student 4. The question is asking which student is both precise and accurate. Which students matches close to
B.
which is it?
B.
Look at the values. Student 1's 3 trials. This is student 2's. This is student 3. This is student 4. 4. Student 4 is both precise. is both precise and accurate. So do you get the idea of what is precision and accuracy? Will you be able to answer such questions?
So that's what we're doing on the back of this.
Are we good? Do you want to do one more? All right. So let me make up a number here. I'm massing myself on a scale. All right. Say I take my mass and first I go to the doctor's office. All right. At the doctor's office, it says my mass should be 120 pounds. Okay. The doctor office put me on a scale, and what is my weight? 120 pounds. I come back after a month. I use a scale that I purchased at a yard sale. I put myself on the scale and it tells me I'm 100.1, 100.2, 99.99. What can you say about my data points? Are they close to the accurate value?
Precise but not accurate.
Casey, it was not your turn. All right?
You asked the question, you didn't
No,
say
I was addressing the other student, okay? Jose, I was talking to Jose, right? So, is it close to 120 pounds? But do you look at these points? 100, 100, 99.9. Are they close to each other? But they are 20 pounds away from 120. In that case, you will say that data points are precise because they're very close to each other. But they're far away from 120. So not accurate, but precise. But if I get value points like 120, 120, 121, 120, precise and accurate. They repeat as well as they are close. Do you all understand this? Okay. Moving on. I told you to do percent error problems. Is that right? On your back of the page. So I provided you with a sheet. This is a percent error sheet. Now please box this formula and write down that you need to memorize this formula. Alright? You need to memorize this formula. Memorize this formula. Now for the lab test, I did give you the formula. Is that right? You could use it. But for the test, do you need to memorize it? Okay. And do you know how to do percent error problems? Substitute these values and practice them. Is that clear? And we'll come back next class if you have any questions. The next, yes, it's part of homework that you have to do. Okay? Now, let's go to the next thing that we are getting into, which is your dimensional analysis worksheet. Now, I want all of you to carefully look at this picture. It's not there in any of your sheets, but just look at this picture. So that is my final answer, right? There's an equal to sign, and the yellow triangle is my final answer. Think of this picture like a math problem. There is a numerator, there is a denominator. So, who volunteers and how did they arrive at this answer? Yes.
Since they were multiplying the circle by square divided by circle, they're able to cross out the circles.
So, are you saying I could cancel the circle and the circle?
Yep.
And then,
Same for the squares.
and I could cancel the squares and the squares, and I ended up with the triangle. Can somebody help me with the next problem? Who volunteers to help me with the next? Yes, Austin. Okay, so I cancel out the stars. Okay, the red is the octagon, so I cancel out the octagon. And what am I left with? So do you see that? I'm left with the heart and the lightning bolt. So this is the idea of dimensional analysis. The problem type that we're going to get into. You cancel things that are in the numerator, units. What do you cancel? Units that are in the numerator with the units in the denominator. So now we are going to go to this worksheet that you had.
You know this King Henry died by drinking chocolate milk. You heard it before? No, sixth grade. Yeah, probably so.
Okay, so yes, chemistry is a lot of math, right? Okay, so I've given you this mnemonic and we're going to do this problem, okay? Okay, now let's see. So I'm going to do this first problem, which is it's an easy problem actually. Okay. So are you all on this paper? Steven, where is this paper? Jack, where is this paper? So as I write on this paper, I want you writing on your paper. You learn dimensional analysis by doing it with me. I know there are a lot of smart students in my class who can just do the problem in their head. Is that right? But there is a certain manner, certain steps that I am looking for that I want you to show on paper. And you will learn that by doing with me. I know you've done such problems before. Is that clear? But I want it my way. You all understand? Okay. So I'm going to write this number down. This is 7.5 and I have liters. The liter is like the picture. Remember in the previous problem we canceled? Remember? So the liter is like my picture. So now I'm going to draw a track.
We'd like you to do that, please.
All of you should be writing that number down, writing the unit down. No, Casey, that's not allowed. You're going to write down what I do on the board and do the problem. Just the way I want it.
I'm going to do it for this, and I'm not doing it any other time. I'm giving you a heads up.
We're going to do this throughout the year, so you're going to do it with me throughout the year. Okay? So, do you understand? Okay? So now, if I need to get rid of the liters, where do I bring the liters? Where do I write liters if I have to cancel it out? In the bottom, Jennifer? Alright. I have to write liters in the bottom.
Bring down the liters.
Alright? Bring down the liters. Okay? This problem is easy in that what do I want to be left behind with? Milliliters. So where should that milliliters be if I finally want to be left behind with the milliliters at the top? Should I write it on the top here? Is that right? So now, but my problem is not yet over. Okay? It is liters and milliliters. I need to know what is the conversion factor. In order to learn the conversion factor, you need to know this mnemonic. King Henry died by drinking chocolate milk. That stands for milli, centi, deci. This is the base, deca, hecta, kilo. Everybody good? So now I'm going to go from milliliters to liters. So this is my liter line. This is milliliters, centiliters, deciliters, liters. Is that right? So if I go one way, the unit is 10. 10 milliliters makes a centiliter. 10 centiliters makes a deciliter. 10 deciliter makes a liter. Is that pretty good? Each jump is 10. So if I'm jumping straight from milliliters to liters, Am I jumping from milliliters to liters? Is that right? How many zeros do I have? 3. And milli is my smaller one. And liter is my bigger one. Is that right? So, I know my conversion factor that 1 followed by 3 zeros, milliliter is equal to 1 liter. Is everybody good? Is everybody good so far? Okay. So my next job is to fill in numbers, all right? To fill in numbers before my units. So I'll use this conversion factor to fill in numbers before my units. What is my number before milliliters? 1000. So I'm going to write 1000 before the milliliter. What is my number before liter? 1. So I'm going to write 1 before the liter. Okay? Please realize that I will not cancel out the numbers, but I'm only canceling the units. So the liter on the bottom will cancel with the liter on the top, and I'm only left with milliliters. Is that right? The remaining is math. This is the number in the numerator. This is another number in the numerator. If there are 2 numbers in the numerator, what do you do with those 2 numbers? You multiply them. Okay? So if I multiply, and then what do I do with the one in the bottom? I divide. Is that right? So if I multiply and divide, I will get 7,500 milliliters. Do you understand the process? So what is the answer to this question? It is 7,500 milliliters. Do you understand the process? Okay. So let's do the next problem. This is, what do I do first? What should I write? Should I always write my given? Is it a 750 milliliters? So what do? I draw my track. Draw the track. So I want to cancel out of milliliters. Where will I bring the milliliters? To the bottom? I write my milliliters on the bottom. What unit do I want to end up with? So where do I write my liters? On the top. So what is my conversion factor? How many milliliters makes a liter? So what number should go before milliliters? 1000. What number should go before liters? 1. Can I cancel my milliliters and milliliters? What is my math in this problem? 750 times 1 is 750 divided by 1000. So if you put it in your calculator, 750 divided by 1000, I get 0.750 liters. Do you understand? Do you understand the process? Okay. Let's do one more problem. So what do I write first? I draw the track. Somebody wants to help me? David, what number do I write here first? 356 grams. David, what do I bring down? You bring grams because I want to cancel out of grams. Is that right? What will I write on top? Kilograms. So David, I don't know the relationship between grams and kilograms. So I'm going to go to this. And this is something you'll memorize and write down. So here is my gram. Okay? Here is my kilogram. Okay? To go from gram to deca is a 10. To go from deca to hectare is a 10. To go from hectare to kilo is a 10. So how many grams makes a kilogram? 1. Yes? Okay. So We know 1000 grams is equal to 1 kilogram. Let's come back here, David. What number goes before grams? 1000. What number goes before kilogram? 1. I cancel my grams. What do I do with the 356 and the 1000? And that answer will be equal to 0.356. What is my unit, David? Kilograms. Do you understand this process? Do you understand what this is? Do you think you will be able to do such problems? Okay, now I am going to skip around a little bit.
We have a table at the bottom of your page. Ms.Geeta is going to project hers. And on the back of your page, we have some conversion problems. Page problem 1A. I think
We'll start with problem 1A.
So flip over to the next.
Okay? So when you take your test, I'll probably give you a quiz at the end of next class on DA. Alright? Look at this table. Such a table will be provided to you. Okay? So every time it's not just a two-step process. Sometimes it's more than a two-step process. Okay? So if I look at this problem, I have 746 miles. Have you all written it out? 746 miles. And have you written out the T-chart? You couldn't find the problem?
Oh no.
It's on the back.
I'm back.
On the back. And it's the very first problem.
I don't think so.
746 miles. Now, this chart is on your previous page. Alright? I do realize I have to go from miles to meters. But let me ask you something. I need to cancel out of miles. Is that correct? Do I need to cancel out of miles? Is that my first step? What will I write in the bottom here? Miles? In order to cancel miles, what will I bring down, David? Miles. Should miles go in the bottom? So, this table does not have a miles to meter conversion factor, if you notice. It has a miles, and this is the only one with miles. Do you notice that? This is the only one given, and it only gives a conversion factor between what? Miles and feet. It does not give meters. I don't panic. That's okay. Alright? So I have miles. What does it relate to? Feet. So what goes on the top here? Feet. So what number will I fill in before miles? Before miles, it is 1. What will I fill in before feet? 5,280. Everybody good? But I look at my problem and I know I cannot stop at feet. I have to go to meters. But now, what is it that I have to cancel out of? So first I was able to cancel out of miles. What is it that I now have to cancel out of? Feet. So what do I bring down here? Feet. So I'm now looking for a relationship with feet in it. Do you understand? I go back up and I look for a relationship. Yes, this one has feet and miles, but then I'll be going in circles, right? I started with miles. So what I'm going to do is, I'm going to look at the next relationship with feet. What does that convert the feet into? And do I want to convert it into meters? So what do I write on the top here? Meters. What do I fill in before feet? What is my number before feet? Feet. What is my number? 3.28. And What is my number before my meters? 1. Can I now cancel my feet? And so I'm just left with the math. Is that right? These three numbers are in the numerator. So what do I do with them? I multiply them, and 3.28 times 1 is going to be 3.28. Is that right? What do I do with the number in the denominator? I divide. So put this number in a calculator and tell me what is your answer. What do you get as your answer? Okay, so I will complete this problem and I will post this. So you do your study guide. You understand?
Like to do that.
Yeah, do the back, do dimensional analysis problem.
So I have
Okay?
keys up here. I have a cell phone, blank planner. Let's see. This is Josh. Josh. And Parker.
This is 1,
Okay, you got your keys.
8, 7, 8, 1, 0, 4, 9. But I need to report to 366. So my answer is 366. Going to be 1, 2,
Parker, don't forget.
0, 0,
There's not yet.
0, which is actually 1.0 times 10 to the
I guess what it is.